Okay, in this video we're going to take a look at what is commonly called a DC sync attack. Now if you don't know what a DC is, or you don't recognize any of this stuff, you don't know what an Active Directory domain is, I would encourage you to go and watch my previous video called Active Directory Basics. I'll leave a link to that in the description. Now it is quite a long video, you don't need to watch the entire thing to get a handle on what we're going to talk about here, but just watch the first sort of 10-15 minutes so that you understand what a domain is and what a domain controller is. So assuming you have watched that or you already understood all those concepts, you should be fine to understand what we're going to talk about in this video. So to start with, what exactly is a DC sync attack? I'll just give a quick explanation and then we'll do a demonstration of it and then I'll explain it in a bit more detail. But as a quick summary, it's basically pretending to be a domain controller. So you can see we've got existing domain controllers in Active Directory. In this domain we've only got one, but in most domains you're going to have several. And they all need to store an up-to-date copy of this Active Directory database, all of the information in here about all of the user accounts, etc. There is actually more to Active Directory than what you see in this domain partition, which we will get into briefly in this video. But yeah, they all need to replicate everything between each other. So if we were to change, say, a user's surname or username or literally anything in Active Directory, that information has to get replicated to all the other domain controllers. And that includes their passwords, because any user, when they log on, they can authenticate with any domain controller. So every domain controller needs a copy of every user's password. Now in this domain, like I said, we've only got one domain controller, but we can still pretend to be another domain controller and ask this DC to replicate whatever information we want over to us. Now obviously there's some permissions that control the ability to do that. You can't just normally do that, but we'll get into that in a minute. So yeah, a high level overview is just we pretend to be a domain controller. We call the relevant APIs and remote procedure call functions to ask another domain controller to replicate over all of the user's password data. So that's how it works in a nutshell, but let's take a deeper look at how this actually happens. So the first thing we'll need before we can do this is permission to actually replicate AD information. If we go to the security tab on the root of the domain, and this is a special permission that can only be granted on the root of the domain, it doesn't get granted anywhere else, we'll see if we go into the advanced view that by default, the domain controllers, so let's have a look here, domain controllers, have this permission called replicating directory changes and also replicating directory changes all. So those two permissions are the ones that we need. That is basically what controls who is allowed to call these remote procedure calls and basically just say, hey look, I'm a domain controller, replicate your information to me. So the main difficulty with this kind of attack is actually getting yourself these permissions, but the most common way is to abuse the Microsoft Exchange Windows Permissions group. If you don't know what Microsoft Exchange is, it's Microsoft's email server service. And if you install that on one of your servers, it integrates with Active Directory. So it modifies a load of permissions and adds a load of groups in here. And one of the permissions that it adds is there's a group called Windows Exchange Permissions. It grants that group permission to modify permissions on the root of this domain. Obviously, I've not got Exchange installed, but just pretend that there's an entry in here in this access control list for the Exchange Windows Permissions group, and it has permission to modify these permissions. So you can get into that group, which I don't think is treated as a proper admin group. It doesn't get its permissions like reset every 15 minutes like proper admin groups do. And it's generally less secured than most other groups like domain admins or domain controllers, stuff like that. But if you can get into that group, you then will have permission to modify these permissions here. So we're going to pretend that you've already done that and that you've somehow got a way to actually modify these permissions. Just for the sake of the demonstration, we're going to manually grant a user account. So we'll use our example account, which is called that. And we're going to grant him the required permissions. So we'll look down here, we get replicating directory changes and replicating directory changes all. There is a third one, but you don't need that most of the time. So now that we've got those two permissions, we can go to a non-domain machine. This is just a complete standalone machine. Let's pretend this is our machine that we're attacking from. And we can run, there's a couple of different ways you can do it, but probably the safest way that's not going to trigger antivirus stuff is if we use Secretsdump.py from Impacket. And because it's from Impacket, the syntax is a bit weird. So this is our domain name for this domain that we're attacking. We need a / and then the username and then his password. So this is assuming that you've already got some basic user credentials. And obviously you've granted them the permissions required. So we do his password, and then I think with Impacket you've also got to do the machine name or the IP address, so we'll just do the machine name. And that is a combination you will never see anywhere else. Domain name / username : password @ machine name.domain name. In like 8 years of Windows admin, I've never seen anything like that, but that's how this Impacket script wants you to do it. I can't actually remember if there's any other options we need to set, but we'll just try and run that to start with. There we go, it works. So I'll talk through how exactly this works and what it's doing in a moment, but for the sake of just giving a quick demo of the attack, you just have to accept that it does work. Like I say, we'll explain that in more detail in a minute. But what this gives us is a list of all the user accounts in the domain. including this special one, which we'll cover in another video when we talk about Kerberos golden ticket attacks. But for now, let's just focus on the fact that it gave us the administrator account and it gives us their password hash. So we don't actually know their password, but we can see their LM and their NTLM hash here. So if we copy those, we can then use another Impacket script like WMI exec or PS exec, or I think the Linux Powershell client, evil WinRM, I think that has an option to do this as well. But with any of those, we can do what's called a pass the hash attack. So even though we don't know the user's password, we do have the hash. So we can essentially use that as a password. So again, I can't remember the exact syntax for Impacket stuff, but I think we want to just do that, and then again, the IP address or machine name. So again, this is the machine name that we're trying to connect to. So because we've got the administrator thing, we don't actually have to put his password in. We can just use hashes, paste what we just got in there, and that should give us access. Yeah, so now if we do who am I, we're now running on that remote machine as administrator. So there you go, that's a very quick example of the attack in action. That is a DC sync attack. I mean, the DC sync attack is just this bit. Like how you want to actually use those hashes is kind of a separate attack. But yeah, that's just a demonstration of what you could do with those hashes. So like I said, there is a more interesting attack with this account in particular, a special Kerberos account, but we'll cover that in a separate video. So for now, let's just talk through how this actually works, like what is actually going on here. What actually happens in this script, in fact, let's take a look at the script itself. We go to Python and then scripts. And I think it's lib, no, I can't remember exactly the path, so let's just try and find this. It's not in script, it's in lib, and then cite something or other, and then Impacket, if I remember correctly. And then examples. Oh, clicked the wrong one. So yeah, so this one, this has got all the classes and everything in it that Secretsdump thing actually uses. We'll edit it with Notepad++. I haven't got a proper IDE for Python installed on this machine, I'm afraid. But let's just find the bit that we want. This part here is what does most of the work. So this, believe it or not, is actually all documented by Microsoft. What this script is doing is just calling a remote procedure call called this, and if we Google that, we will see that Microsoft actually documents exactly how to call this. You see the first few examples we get are actually just people talking about this attack. But here we go, this is the actual Microsoft documentation. So this is that DRS get NC changes remote procedure call. And the whole point of it is, like I said, for domain controllers to get updates to Active Directory partitions, basically. I'm not going to go through all of this, but if you're interested, this is basically the part that actually specifies all of your options, and it's version 8 that Impacket uses. So here you can specify all sorts of options, such as the actual list of attributes that you want to get, and some various other options. You'll see in the Impacket script, we'll have a quick walk through what it's doing. So it sets this P message in, which is what we just looked at. That's what this is. And then version 8, like I say, this is the version 8. And it sets, where are we? This UL flags option, which I just mentioned, gets set to one of these combined options. So we're setting it to init sync and write rep. So init sync, I assumed initially, it says here the definition, perform replication at startup. I assumed initially that init sync meant, like the first time when you promote a new machine to be a domain controller, it has to synchronize everything over from the existing domain controllers. Whereas normally when a domain controller is just doing its normal stuff, the only things that get replicated are changes. So the only time we'd ever actually get a user's password using this method would be if the user changed their password, because then the changes would get replicated out to other domain controllers. However, when you first promote a domain controller, it needs to just synchronize everything, like I said. So I assumed that's what this was saying, was just kind of synchronize everything as if it's an initial sync. But from the description here, it doesn't look like that's the case. So I'm not so sure if that means what I think it means. But yeah, the ds write rep just means it's a writable copy of the database. I don't actually know why this needs that, because we only need to read stuff, but I don't know, maybe passwords don't get sent over with read-only domain controller stuff. But yeah, the kind of interesting bit for us is when we look here, this structure here that they loop through and basically set in this partial attribute set. So if we go back here, again, don't worry too much if you don't understand all this stuff. I'm just kind of doing a bit more of a deep dive rather than just saying, look, it works, that's it. I want to explain a bit more of the actual inner workings, but you don't need to understand all this. And there's stuff that I don't understand in this. The remote procedure call is very complicated and messy, and I've got to say big hats off to Impacket for implementing all this stuff. But yeah, so this partial attribute set here is where you basically list the attributes that you want to get a copy of in the replication data. So if we look at what they're actually setting here, it's this type here. We'll have to do a search because, like I said, I'm not using an IDE, this is just a text editor. So here we go, this is the definition of that. And basically this list of attributes and their corresponding OIDs, this is what it's going to get for every user account. So the important one, you can see it's just getting the username. Again, that's the old school username. That's the newer version of the username. But the important one really is this Unicode password or Unicode PWD. That's where the user's password hash is actually stored. These ones are just like the user's old passwords because it needs to keep track of passwords in case the user tries to reuse the same password and you've set your password policy not to allow that. But yeah, this one is the main one where we're going to get the LM and the NTLM password hash. It also grabs the user's SID as well, which you'll see later on why it does that. Well, actually, we can show you here. You see here it's giving you the SID or the relative ID, the end of the SID. In this section here, I guess that's so that you can identify which user accounts are which, because you can rename the administrator account to something completely different. So then you wouldn't know it's the admin account, but with the SID or the RID, you know that 500 is always administrator. So yeah, then the only other things it's just outputting is the values basically from that Unicode password attribute. And just to clarify, you can't normally ever read this attribute. Like if you try and do an LDAP query, even if you're running as admin, you can't access this attribute at all. It can only be accessed by system processes like this DC synchronization or replication process that we're talking about here. If we go back to where we were, I don't think there's really anything else to cover it. Like I say, it loops through all those attributes we just looked at, says that it wants to get a copy of those, and then it sends the request and obviously passes the result. Again, you can see in the Microsoft documentation exactly how the result will look, and then you can pass it. But again, it's not straightforward. Like it is something that I want to try and do, is actually run remote procedure call stuff myself, but it's a bit daunting when you first start, especially when you've not got that much experience with C and C++. So yeah, that's how that works. That's what it does. You can see it build all this stuff up, like we said, sends a request off, passes the result, and then we get all the information. There is another tool that can do this called Mimikatz, and the reason I said that this way was a bit safer was because with Mimikatz it gets flagged a lot by antivirus stuff. I mean, if it's already been deleted from this machine that I'm using now about 3 times by just the built-in Windows Defender stuff, even though I keep turning it off, it still deletes it over and over again. But if for some reason there's no antivirus at all on a target machine, you can just copy Mimikatz over and do the DC sync from there. I'll show you briefly what that looks like. If we have a look in here, it's x64. If I could type, and then yeah, it's in there. So if we run that, you get this little sort of console, and if you're running this on a domain controller or whatever machine you're trying to access, you can just do, let's say, dump DC sync, and then you do have to pass in a domain name and stuff as well. And there's examples online of how to do that. But like I say, this method gets flagged by everything, so I would say you're much better off doing it remotely with the Impacket script, even with all of its weird syntax stuff. One thing to quickly point out as well that I forgot to mention is that I've already set my DNS server to point to this domain controller that we're attacking. So if you didn't have that, then you might need to just use the IP address here instead of the machine name. So yeah, that's just something to bear in mind. So let's take a quick look at how you could actually find out if a user account has been given these permissions that we need. So let's just as a refresher, let's go back to this server that we've got here. So yeah, those permissions that we needed on here, these permissions here, this replicating directory changes, how could you check and see, especially on CTF machines, you know, this is much more common that these permissions would just be granted to a user. In real life, I don't see anyone ever granting those permissions to a user. Maybe for like Azure Active Directory sync or something like that, it might require a user account that then has permission to sync everything from the domain, so they can synchronize your local domain with the cloud domain. Maybe for stuff like that, you might actually find a situation where a user account has these permissions. Just to clarify as well, normally the permission would only be granted to computer objects. As we saw, it should just be granted to domain controller computer accounts, but there's nothing stopping you granting any permission to any type of object. So if you can grant a permission to a computer account, you can also grant that permission to a user account. So we're kind of taking advantage of that weird little feature of AD permissions, I guess. So let's go back to our attacker machine, and we'll just do a PowerShell session. We'll do a remote PowerShell session. Again, this is assuming you've already got some credentials and you've got a way to actually get like code execution on the remote machine or a remote shell like this. We'll go to the server, which I think that's the IP address. I don't know why I didn't use the machine name, because I've got DNS working. But if we put in his password of this basic user account that we've got that's not an admin or anything, if we wanted to enumerate permissions on the domain and see if anyone had been granted those special permissions, you have to ignore the weird user folder that was from me just testing something. But yeah, we can run the dsacls command, which is a built-in command on server OSs that have got the Active Directory role installed. So we can run dsacls and then just pass in the distinguished name of what we want to check. So in this case, it's the root of the domain. If you don't understand this weird domain format, then go and watch the previous video on Active Directory stuff. I'll explain distinguished names in that. But yeah, if we run that, we'll get a list of all the permissions. There is a way to do it in PowerShell. Like obviously that's just using a native Windows command. Here we can see those permissions that we were talking about for our T-star account. There is a way to do it in PowerShell, but it's pretty ugly. First thing we need to do is import Active Directory module. And you'll see why I'd much prefer the DSACL's version in a moment, even like forgetting the fact that this takes a lot more typing and whatnot. So we can use get ACL, and then we'll do the AD drive. That's why I needed to import that. And then we'll say the root of the domain again. And first of all, you get a terrible output. Doesn't really tell you anything. But if we pipe that to select object and expand the access property, because that's what actually contains the ACL basically, you can see we get this, which looks horrendous. And in a lot of places, it just has GUIDs instead of actual display names, which have to be looked up in another part of Active Directory, which I'll go into very briefly now, but I'm going to cover this kind of stuff in more detail in my AD permissions video that will be out soon. You can see here, we've been granted, so this is the actual permission that we're talking about, T-star, it's been granted an extended write, whereas some of these are just like being granted to read properties or write properties. And then that specifies what type of property it is that they can read. So say the user's username or a user's surname or something, that'll be like a GUID to represent a certain property. And this is saying they can read or write that. But here, when it's extended write, then this object type actually means an extended write. And then you can also have validated writes and all sorts of different stuff. So it's not particularly straightforward because all these GUIDs have to get looked up in different places depending on what value this has. So again, it's not straightforward, but just to show you where you would look up those extended writes, if we open up ADSI edit, which is essentially like this AD users and computers console, but in a bit more sort of low level. Like you can see here, we can see the same stuff in here. So we've got built-in, and we've got built-in here, computers, and we've got like all the same objects and everything. We're seeing the same stuff. But with ADSI edit, we can connect to other partitions. So this that we're looking at here, this domain part, is the default naming context. If we look at the configuration context, we can see a load more information that Active Directory uses for various things. And one thing we can see in here is extended writes. Now, if we expand this over here, and we'll look for the replicating get changes all. Now, if we look at the writes GUID attributes, so this one here, writes GUID, you can see that's 1131 blah blah blah. And if we go back to here with our T-star account, we can see we've been granted 1131 blah blah blah, ends with DCD2. So you can see that's the same GUID that we're specifying here. So if we were trying to find out the actual display name for that, we'd just search for this writes GUID being set to that, and then look at the display name property, which is replicating directory changes all. So there you go, that's how it actually works in the background when a tool like DSACL's converts those GUIDs into readable text. But yeah, I wouldn't use the PowerShell method because you've got to manually convert all that stuff. Obviously you can script it, but like I said, with all the different ways that this can work, it's not particularly straightforward. So like I said, I will do a video explaining AD permissions in more detail and also Kerberos golden ticket attacks, but to end this video out, let's just have a quick look at how you could actually grant yourself those permissions if you were in the Exchange Windows permissions group. So that's a scenario where you've got permission to change permissions, but you haven't actually got these replicating directory permissions yet. So let's have a quick look at that. The easiest way is if you Google PowerShell AD sync permissions, something like that. I can't remember what it was that I did the first time. Okay, so I can't remember what I searched for originally, but I ended up stumbling across this script here. And they basically explain the whole issue again with Exchange Windows Permissions Group having these permissions. And like I thought, and I've mentioned in a previous video, I think this is kind of a bug, and they kind of agree here, but Microsoft don't want to fix it. I'm not going to explain it in too much detail, but basically there's an option you can set when you're setting permissions that they've kind of set in the wrong way, it looks like, and it just means that instead of it only applying to child objects of a certain type, it applies to the root object and the child objects of a certain type. So it's pretty weird, but Microsoft has said they're not going to fix it because it works. And yeah, it's a bit weird to me. But anyway, this is the bit we're interested in. You can literally just copy and paste this script into a PowerShell session that you're running. You don't need to save it as like a PS1 script and import it or anything like that. Just copy and paste this. And you will need to change the domain name here to whatever domain you're attacking, here and here. But the rest of it is good to go. It just uses those GUIs that we talked about to grant you those same extended writes, which are the directory replicating changes things. And then, yeah, it'll set them on the root of the domain. So if you're in the Exchange Windows Permissions group, then you can just run this, grant yourself the DC sync permissions basically, then run the Secretsdump DC sync attack. Or like I said, you could copy Mimikatz over and run that, but chances of that actually working are pretty slim. So yeah, that's probably it for this video. Like I say, there'll be other videos coming out very soon, which will use the same kind of setup as this, but then we're going to focus on this account to do a Kerberos Golden Ticket attack. And there will also be a general AD permissions enumeration and just general AD permission stuff video very soon as well. So yeah, I hope you found some of that interesting, and I'll see you in the next one.